We both come up with research or research that we want to do, as well as and you said you were if you want, I can contact you before you go to the country. But I'm still going back to the yeah. He said if you have any questions, feel free to reach out. So that's
all right. Good evening, everyone. How is everybody? Good. Okay. Are there any questions? Anything? I will start the class by a reminder about important due dates. The important due dates is posted on the course outline. If you read the course outline on Drive Space, this is one page. We have an online assignment due Thursday. This Thursday, January 19 at 4:30 on web assign, online assignment, web assign. There is no extension. Please complete the online assignment well ahead of the due date, as unforeseen events do occur, technology glitches, okay? Another important date is January 20th, is the last day for the registration. You are here, I assume you already registered, okay? And then January 26th is our written assignment due. Written assignment is to be submitted to the cloud mark, okay? So this is about the important due date. Any questions? About the, yes.
So in regards to the written assignment, do you want, when it's submitted to everyone, do you want it as a PDF or?
Thank you. When you submit your written assignment to CloudMark, you can submit as a PDF or as a picture. Take a picture of your written assignment. Okay, you have to submit question by question. I will show you how it looks like for the CloudMark. Give me 1 second. I haven't posted anything on 1p97 yet, but I am also teach start 1p98. I show you how it looks like when you submit your assignment, okay? So I have one assignment here. This is for 1p98, not for this course. Just to show you how do you submit your assignment, written assignment on CloudMark, okay? So you have questions, okay? You have questions, and then you click question, and then you submit, enter your solution here. So you take a picture of your question 1 in PDF file. You do this question by question, submit each question, okay? You will get an email invitation in few days, maybe tomorrow, maybe after the day after tomorrow, okay? For our first written assignment. Okay? So this is how you submit your written assignment to CloudMark. Okay? So that is the important due dates. And about the course content, last week, we did chapter 1. We started 2 sessions of chapter 2, or 3 sessions, session 1 to session 3 of chapter 2, okay? There are students have confusion about online unit. Online unit is only for online students. You are registering for Monday evening class. This is in-person class. So you just focus on textbook section. Forget online unit. Remember, we have 3 different sessions. We have Monday evening session. We have daytime, Tuesday, Thursday, Friday section. And we have online sessions, 3 different sections, okay? For this Monday class, you just focus on textbook section, that's it. Forget online unit. We do not have online unit for in-person section. So today, as you can see, we will cover chapter 2, section 4, and section 5. Okay. Another commonly asked questions about softwares used in this course. For online assignment, you will use WebAssign. The WebAssign is on the Brightspace. So if you go to the Brightspace, you have the links. It is give you the WebAssign registration help. So read it. If you haven't registered, read this help information first, then you click this website. In order to register, you have to buy the textbook through the campus bookstore here in order to access WebAssign, okay? Once you get the access code, you register for WebAssign. The online assignment is here, so WebAssign. Okay, this is your written assignment 1. This is your written assignment 1. Okay. It is due January 19th. Okay. You can do this assignment many times. The highest mark will be recorded. So just complete those questions, okay, and submit for, after you complete all the 10 questions, submit. It is equivalent, if you took START 1p98, we use MyLab, and this is the MATH1p97, we use a web assign, similar software, okay? This is your online homework. So try to do many times as possible. The highest mark will be recorded, highest mark. So this is one software we are going to use. You need to purchase textbook in order to access this software. Another software is free. That is the GeoGebra. There is a tutorial here, the guide on how to use GeoGebra. And in class, I will do some demonstrations, okay? And our written assignment 1 will have about 2 questions using GeoGebra, okay? So those are the 2 softwares we are use. Any questions? Yes.
So in regards to the online assignment, like if you were to, like, if you were working on the 10 questions, let's say you did 1 through 5, and you want to take a break, if you were to go back, will it save the answers you had already placed in without submitting it, or will it get rid of it if you didn't submit them completely?
Thank you. It should save your, anyone, did you have a try? If you just do a few questions, you left. Oh, thank you so much. It is saved. Thank you for helping each other. Yes. Correct. You have unlimited trials. You can do 5. Oh, I'm sorry. I thought in maybe different semester, different. Thank you so much. You have 5 attempts, 5 trials. The highest mark will be recorded. Okay. Other questions? All right. After class, if you have questions, I have suggestion from Monday to Friday. If you have any questions, you can email me, okay? And during the weekend, Saturday and Sunday, if you have questions, if you can hold the questions until we meet here on Monday evening, that's great. If you cannot hold your question, you can email me during the weekend, okay? But your questions are welcome during the weekdays, Monday to Friday. Weekend, I suggest you hold your question, ask your question in class, any question, okay? All right, so. Week 2, Chapter 2, Section 4, Limit. The concept of the limit has to do something with the tangent line. Remember in high school, what is a tangent line? It is a line touched to the curve only once. A straight line touched to the curve only once. In this example, you have a point P, touch the curve only once. There's a straight line T. So the concept of calculus coming from the tangent line. Several 100 years ago, a famous mathematician, Isaac Newton, and Gottfried Wilhelm Leibniz, they invented this tangent line problem. And they also invested the area surrounded by some curves. So they are interested in how do you calculate this area, irregular, not rectangular, not circle. How do you calculate those areas? So those concepts simulated the thinking about calculus. So calculus is actually about the derivative and the integral. This concept of tangent line, we need to find out the slope of this line. Okay, if you find slope, you have a point, you can write down a straight line. Yeah. And for this is actually derivative. And for this area, it is actually integral calculus. So we use this sign represent integral, means I want to calculate the area of this irregular shape. Okay, let's take a look at the real life example. So this example about a prototype of a maglev, which moves along a straight monorail track. Engineers have determined that the position of the maglev from the origin at time t is given by s equal to 4t squared. So f is called the position function of the maglev. If you want to know the shape of this curve, high school, you know this is the parabola. If you want to know exactly what this curve looks like, you can use algebra. So now I will demonstrate how to get a picture of this graph using algebra. First, you go to this website, www.geogebra.org/CAS. And then in the input, you type in the function 4t squared. Typing square, you use that symbol. To type in square, you type in 4t, and then this symbol 2. It will change to 4t squared. Like in Excel, you type in the exponent, okay? So after you type in this one, see, you automatically get this curve. This is 4t squared. Okay, this is 4t squared, how it looks like. So this is an example, okay? In this example, if you say what is the f value, so this is ft equal to 4t squared. You take some value for t, 0, 1, 2, 3 until 10. You get the value for f. Okay, you get the value for f. What is the question here? The question found the velocity of the maglev at t equal to 2. So how do you find the velocity? Okay. And we do step by step. To find the velocity, we want to find out, this is t equal to 2. Okay, and we want to find out when t very close to t. So what are the values very close to 2? You can try when t equal to 2.5, what is ft? So when t equal to 2.5, ft by definition, ft is 4t squared equal to 4 times 2.5 squared and equal to 18. You got ft, okay, 18. Similarly, when t equal to 2.1, what is ft? Keep on going. When t is very close to 2, so 2.0001 is very close to 2, and you got this number. Okay, so to find this question, find the velocity, we use average speed, average. So average, because we want to find at the t equal to 2, okay? So the general format for the average, so from t, 2 to t, what is the average over 2 to t? Okay, this is the formula, the average velocity over 2 to t. We use ft minus f2 over t minus 2. And what is ft? By definition, ft is 4t squared. And what is f2? Plug in t with 2, you got f2. Okay, so you end up with this one. You end up with this one. And then if you simplify this one, on the top, t squared minus 4 is the same as t minus 2 times t plus 2. On the bottom, you have t minus 2. So t minus 2 cancelled out. On the top, you just have 4t plus 2. Okay, so you got the average velocity over 2 to t. And now, the question asks you, at t, what is the velocity at t equal to 2? So what we get right here is the average from 2 to t. If we allow the t approach to 2, approach means go very close to 2. When we allow t, we use this symbol, t approach to 2. So t very close to 2, and this 4 bracket t plus 2, close to 2 plus 2 equal to 16. Okay, when t very close to 2, we get the velocity at t equal to 2. How did we get at t equal to 2? First, we get the average over 2 to t. Second, we make t approach to 2. Okay, so our final result is 16. And this approach, the concept of approach, we use mathematics, we use this limit. Okay, we use this sign. Limit means when x approach to a, fx approach to L. This is the definition of limit. Okay. For example, in this graph, when t approach to 1, so we have 1 here, t approach to 1, if you go up here, ft approach to 4. Okay, see here, this is 1, number 1, where is my mouse? When x approach to 1, ft approach to 4, this is 4. Okay, so I'm just going to make a note here. So in this example, when t approach to 1, you go up, ft approach to 4. So when t approach to 1, ft approach to 4. And we have a simple way to write down this. We say limit when t goes to 1, ft goes to 4. So the same thing as here, when t approach to 1, ft equal to 4. So hope you understand this expression, the definition about limit. When t approach to 1, ft approach to 4. The general definition, when x approach to A, fx approach to L. Okay, so in this graph, if I have any graph, so if I don't say this is number 1, I say this is number A. So when t approach to A, I don't say this one is 4. I say this is L. Okay, so in this example, limit. Okay. When t goes to A, ft goes to L. So this point is L, this point is A. Okay. So that is the definition of limit. Any questions? All right. So this example, as you can see, the curve is continuous. There is no broken point. So it is very continuous, it is smooth. Okay. This example will see a piecewise function. We have a function gx. There are two situations. When x not equal to 1, it is equal to x plus 2. When x equal to 1, it is equal to 1. Okay. The question asks you, evaluate limit when x approach 1, what is gx? That is the question. Okay. So we can use algebra graph to get a sense of what is x plus 2 looks like. We know it is a straight line for sure. X plus 2 is a straight line, okay? So now I'm going to produce x plus 2. This time I will close this line. If you do not want to show the line, click this circle button here. See, the curve disappeared because I click this circle button. If you click it again, it is on. So look like on, off, on, off. Just click this button. The reason I want to take it off, I want to show another curve. Okay, so this curve would be x plus 2. So this is how x plus 2 looks like. Okay, x plus 2 looks like. So what is the question here? The question asks us, so I got x plus 2. It is only when x not equal to 1. If x not equal to 1, it is x plus 2. Did I type in plus or minus? X plus 2. Yeah, which is this one. Okay. Okay, so this x plus 2 has a condition. What condition? When x not equal to 1. So I will take a circle here because this point is when x equal to 1. The question said when x is not equal to 1, it is the blue line. What happened when x equal to 1? It is said when x equal to 1, the gx equal to 1. Okay. So when x equal to 1, gx equal to 1. I need to find where is 1. So it is here. When x equal to 1, gx is 1. When x is not equal to 1, gx is this blue line. Okay, not including this point, because this point said when x equal to 1. Okay, maybe I try to find, use another color. What exactly is the color? Try to use maybe green. Okay. So, try to change my color. If you see the color green, that is the function. The green straight line here, green here. So when x equal to 1, it is equal to 1. When x not equal to 1, it is from here and from here. Okay. Okay, what is the question here? I understand the graph. The question asks you to find limit when x equal to 1, what is gx? Okay. What does it mean when x goes to 1? So when x very close to 1, when x is very close to 1, this one means x close to 1. Close to 1 means not equal to 1. X close to 1, close to 1, close to 1, but not equal to 1. So you tell me, which one do I choose? Is this one, x goes to 1, belong to the first condition or the second condition? I have two functions. One is x plus 2, the other is 1. Which one do I use when x goes to 1? Yes.
I want to find something close where you use x because it's not exactly equal to 1.
Excellent. When x goes to 1 means very close to 1. You should use x plus 2, not use x1. Okay, so the answer is 3 because you plug in x equal to 1. Okay. Okay, the same question, I give you another question. Given gx equal to this, this is question A. Question B, find the limit x goes to 2 gx. What is the answer for x goes to 2 gx? Anyone want to try? Yes. 4. How did you get 4? 2 plus 2 equal to 4. Okay. So this is another example. Any questions? All right. This is the properties of the limit. Okay. I will try to use some examples. We have examples here. So the first one said, when you raise power to the function r, when you take limit, it is the same as take limit first, then raise to power r. They are the same thing. The second property said, when there is a constant, c is a constant, constant times fx, take a limit, it is the same as take the constant out, then find the limit. Property 3 said, if you add 2 functions or subtract 2 functions, then take limit. It is the same as find the limit first, then do addition or subtraction. Next one, if you have 2 functions times together, then you take limit. It is the same as take limit for each function, then do multiplication. Okay, same thing for the division. If you want to find this is 2 functions, do the division. It is the same as find the limit first, then do the division. Okay. Any questions? Okay, let's do some problem. Okay, let's do some problem. As you can see, I just provide one solution. The rest of them we are going to do it in class now. So the first one, found the limit. When x goes to 2, x raised to power 3. Okay, so it is the same as found the limit first, then raised to power 3. So 2 raised to power 3 equal to 8. Okay, so this is question 1. Okay, question B. Question B is the same as 5 is constant. We can take this 5 out, then limit. Do limit, x goes to 4. And x raised to power 3 over 2. Just want to change my color to blank. So equal to 5 times, when x goes to 4, you just plug x with 4. 4 raised to power 3 over 2. And what is this? It is just square root of 4 raised to power 3. Okay, of 5. And 4 raised to power 3 is the same as 4 raised to power 2 times 4. Actually, we know this one. Uh, 4 raised to power 3 is 64, square root of 64, equal to 8, and the final answer 40. Okay. Questions? Okay, part C, question C. So limit x goes to 1, you just plug in 1. So equal to 5 times 1 raised to power 4 minus 2 equal to 5, 1 minus 2 equal to negative 5. That is C. Yes?
I just have a question on B real quick. Is it 3 over 2 because you're starting from 5x to 4,000?
3 over 2.
Yeah, I'm just wondering, was that because of the exponent subtracting by 2 out of that, or am I missing it?
So the original question said x raised to power 3 over 2, right?
Oh, sorry, my bad, I'm thankful.
Okay, no problem. Thank you for asking. Any other questions? Okay, now let's do question D. Question D. Yes, questions? For question D, you just plug in 3. Wherever you see x, you plug in 3. That's it. So question D, whenever you see x, plug in x with 3. Whenever you see x plus x with 3, that is question D, because of all the properties we have. Okay. And then 3 raised to power 3, 27, and then square root of 16, 9 plus 7, 16, and continue. So 2 times 24 is 54, square root of 16 is 4. So 216 is D, question D. And the last question, question E. Whenever you see 2, plug in, or whenever you see x, plug in 2. So on top, you have 2 times x. X is 2 raised to power 2 plus 1. On the bottom, you have 2 plus 1. Simplify the top. 8 plus 1, the bottom is 3. The final answer is 3. Okay, questions? Yes. What is C? I'm sorry, I didn't get your question. Which question? Question C. X goes to 1. Oh, thank you, I did it wrong. Question C, so 5, not 5 times bracket. Yeah, thank you so much for your observation. Nobody pointing out. Okay, guys, wake up. Okay. So question C, sorry, question C. Whenever you see x plug in 1, so it is 5 times 1 raised to power 4, bracket here, then minus 2, okay? Thank you so much for your observation. So 5 minus 2 equal to 3. Any other questions? All right, yes. So everything we talked about is the limit. When the first one, question A, when x very close to 2, what is x cubed? X cubed very close to 8.
So is that where, let's say graphically, the line that you showed?
Can we do the first one using the graph? The first one, x cubed, when x equal to goes to 2. We are going to explain this in graph. Okay, item A, x raised to power 3. So this is how this graph looks like, x raised to power 3, okay? So question A asks you to find out what is the limit of x cubed when x goes to 2. So this is the graph of x cubed. When x goes to 2, this is 2, right? This is 2. So when x very close to 2, when x very close to 2, there are 2 situations. Do the x goes to 2 from the left or x close to 2 from the right? Okay, so let's see situation 1. When x goes to 2 from the left, you are here, right? Very close to 2, very close to 2. And what happened for this y, I should have here. So when x very close to this 2 from left, okay. So this is 2. When x very close to this 2 from left, what happened? So let's say when x equal to 1.5. When x equal to 1.5, it is maybe here. This is y. when x equal to 1.8, maybe here, maybe, okay, just roughly. And then when x very, very, very close to 2, it is very close to 8. Did you see that? When x goes to 2 from left. Now, when x goes to 2 from right, let's say 2.5. 2.5 is at the right-hand side of 2. When x equal to 2.5, so I don't have enough space, maybe y is somewhere here. When x goes to, for example, 2.2, maybe somewhere here. So now, when x very close to 2, it is 8. Both directions give us the same result. When x very close to 2, x cubed goes to 8. This is a diagram. Okay, thank you for asking. Yeah. Okay, so we did the evaluation for the limits. Next, we are dealing with a special form we call intermediate form, 0 over 0. I will ignore this description. I will give you example. Okay, you can read this description later after this example. Okay, let's find out what is the limit when x goes to 0. What is the limit when x goes to 0? So far, our strategy is whenever you see this h, you plug in 0. So let's plug in. Whenever you see h, plug in 0. This is on the top. On the bottom, whenever you see h, plug in 0. Okay. And now on the top, you have 1 minus 1, 0. On the bottom, you have 1 minus 1, 0. So this is this situation we called intermediate form, 0 over 0. If this situation happened, we need to do some manipulation first. Okay. So how do we do manipulation? We want to take away the square root on the top. How do we take away square root from the top? So this is an so let's do this. Let's simplify this first. Let's do what is 1 plus h minus 1 over h. Let's do this. I will not call simplify. This is actually simple. Let's do this. Do you agree this one is the same as? This is fraction. For fraction, both the top and the bottom, I will multiply the same item. The fraction will not change. Do you agree? So this item, I multiply square root of 1 plus h plus 1. The top, I multiply square root 1 plus h plus 1. On the bottom, I multiply the same item. It is still hold true. Okay? And now, remember in mathematics, you have formula a minus b times a plus b. What is the formula for this? Anyone remind us? What is the formula? What is the result of this one? A squared minus b squared. Okay? So we apply this to this top. So it would become square a squared minus b squared. This is something on the top. Is that clear? Something on the top. On the bottom, you have h square root 1 plus h plus 1. Now simplify the top. Square and square root cancelled out. Square and square root cancelled out. You have just 1 plus h minus 1. On the bottom, you copy down. Okay. And now, 1 minus 1 cancelled out. On the top, you just have h. On the bottom, you continue copy down. And did you see h on the top cancelled out h on the bottom? So you have 1 over square root of 1 plus h plus 1. Any questions? Okay, we take away the square root from the top, but now the square root appeared on the bottom. But this does not matter because when you take limit, when you take limit of this one, and when h goes to 0, when you take limit of this one, so what is the limit? Whenever you see h, plug in h with 0. 1. You get result, 1 plus 1. The result is 1 over 2. You found the limit for the original expression, 1 over 2 is the answer for the original one. Any questions? Okay, shall we take our fourth break? Come back at 7 o'clock, we continue, okay? So, break back at 7. Yes.
I just wanted to make sure I had this concept right for limits.
Sure.
When we were going over the equation, limit g1 equals, sorry, not that, when we were trying to figure out which equation we should use regarding 4t squared minus 4 times 2 squared divided by t over 2, sorry, t minus 2, I wrote that when using limits for two equations that can get you close to the answer rather than the actual answer. So, sorry, I know this is very confusing. But when we're trying to find an answer for an equation using limits, we shouldn't use the equation that already has a potential answer, but one that has a variable that could shift around that we can use to get the answer.
I'm sorry, to be honest, I don't quite get what is your question.
Okay.
I'm so sorry. But the concept of the limit is when, mathematically, usually we have x, we have y, we have fx.
Okay.
Right? Okay. And this fx could be any curve. Okay. And the concept of when x goes to a number, what will this fx goes to? In this diagram, when x very close to this a, close to a or close greater, so you go up, fx close to this guy here. So this L is the limit of when x goes to a, fx goes to L.
Oh, okay, so I know this might be wrong in terms of thinking, but with lines like this, you should think of it like as a wave and see which each point of the wave meets. Say this is the bottom of something and there's a wave up here.
Yeah, exactly. So this is something about x, this is something about y.
Okay, so
fx is about y.
Okay, perfect. I know that seems pretty simple now, but like that's something that's always been tripping me up. Thank you so much.
Thank you for asking.
No worries, thank you.
Hi.
Are you posting the recordings online?
I don't, because, yeah, okay. Yeah, you're welcome. This is in-person class, yeah. Hello. Good.
I just have a few quick questions. I just wanted to make sure that I was understanding.
Oh, sure.
So when we're looking at like the function here, I understand always comes from the average velocity, right?
Okay.
So then I understand that the average formula is here. Like the t minus 2, is that standard in all the formulas, or does that 2 at the bottom come from the 2 here?
So based on this data, from 2.5, 2.1, 2.01, 2.001, so we are approaching 2 from right hand side, from 2.1, 2.4, 2.3, 2.0001. And that's why we write down t minus 2.
Okay, so if it was a different question, would this not be 2? Or would it
No,
still be 2?
no, not always true.
Okay, so
As,
we changed the
but yeah, if you change parameter, this one is just example.
Okay.
I could write down, if you go up, this 2 could be, I defined the velocity at t equals 3, at t equals 5.
Okay, so if this t equals 3, it would be t minus 3,
Correct,
right?
correct.
And then, did we use like any of the information from this chart?
For the limit,
Yeah, like
okay, good question. What is the purpose of this chart?
Yeah.
The purpose is compare this 16 with this 16.9, they are very close.
Okay. And then, alright, I think that was it.
Okay?
Thank you.
You're welcome. Yes.
The thing that we just did, I didn't understand how you went from here to here. So I did
Did you see 1 minus 1?
Oh, okay.
1 minus 1 is 0. So only h left on the top. And this h cancels with the bottom, you have h cancels out.
Oh, okay. And then when you're multiplying each by each, it gives you one of them.
Yeah.
Thank you.
Yeah. Hello.
And where are these numbers coming from? Like, is it just plugging?
Good question. You are not alone. You understand. Thank you so much. I will explain this after. Where did number come from? Did you go up? Go up again. Do you see this st for the 4 square?
You just plug that number into t.
Exactly. Exactly. Plug in t equal to that number in the end result, the table.
It wasn't like adding up when I was doing it. Like I got, we got like 25. 2.5. If we did 2.5 squared times 4, it's just 25.
Oh, they asked you the average. Thank you for asking. 2.5. Because you have to do the
Is that like a typical
average
formula?
Average using this formula.
Oh, is that
Use
always the average formula?
It's always the average
Okay.
formula.
So you plug,
Yeah.
so you plug 2.5 into there as
Yeah.
t.
Yeah,
Oh,
2.5 here, 2.5 here, you
Right.
got 18.
Okay.
Okay,
makes more
so,
sense.
yeah.
So you don't
So
put it
how do
into
you
the
get
function.
this 18? You plug in t equal to 2.5, you get that 18. How do you get it 16.4? You plug in t equal to 2.1. When t equal to 2.1, plug in this, the result 16.4.
Okay, that makes sense.
Okay.
And then one more bit. How do you get -1 squared? At the top.
Okay, if you go the previous step here,
Page 12.
thank you. So this part, both bottom and the top, we modify the same expression.
Right.
Okay.
And you always do the like opposite operations that.
Always do opposite operation in order to get rid of this
Rid of it.
square,
Okay.
square root.
Okay. Because
Oh, you'll multiply it in and then it'll cancel out.
Yeah,
Okay.
okay. You always multiply the opposite one. Minus 1 is now plus 1.
Right.
So that you eliminate the square root.
Okay. And then why is it 1 squared?
Oh, okay. Remember,
Oh,
this
A squared.
b is 1. So
Right.
according to the formula, you could write down directly 1. That's fine because we know 1 squared is 1.
Okay.
But I want to apply formula here.
Right. So this is technically our A and the 1 is our B.
Exactly.
Okay.
So this, in this, what is A? A is the square root of 1 plus h. B is 1.
Okay. And then you just follow the formula.
Yeah.
Okay.
I have a question from the homework. So for this, the textbook said the answer was supposed to be this and then -1, but I don't know where they got the -1 from.
Can I copy the question? What is the question?
So it says find this.
Find f2 plus h
A.
minus,
Sorry, that's
oh,
an A. My A's are kind of weird.
minus fa
Over H,
over h.
and then this is the function.
Oh, thank you. Do you mind if I explain this in class?
Sure.
Because this is good question.
I know.
F(x)
We didn't go over this in lecture, right?
We did similar things. See, we
In the first one?
not first one. So this question is the similar to here. You do the average, speed. Yeah, here.
So I was
Similar,
getting ahead.
exactly similar.
Yeah.
Different form. See, this is the same as this one.
Yeah.
Okay.
Okay. So I will go over this in 1 minute.
Okay. Sounds
Okay.
good.
Yeah. Thank you for asking. Yeah. Yes. If you don't mind, I will copy the question here. Copy your question. I will explain to the whole class. What is your question?
It's simplifying the expression. So
Okay.
it's 80t squared plus 40t plus 5 over 16t squared minus 1.
Minus 1. Okay. Thank you. I will explain in class.
Okay,
Thank you.
thank you.
It's in the
All right, welcome back from break. During break, I got some questions I think I would share with everyone because those are very good questions, has representations. I would thought maybe some other students having the same problem. The first question is, if you know fx equal to x cubed minus x, find fa plus h minus fa over h. This is the question, okay? So solution. So copy down the top. So I will directly use this one, okay? So this one equal to, whenever you see a plus x, whenever you see x plug in a plus h, that is the meaning of what is fa plus h means. When I focus on this x cubed minus x, When you see x, plug in a plus h. Just plug in. When you see x, plug in a plus h. So this is f bracket a plus h. The next one is fa. What is fa? Whenever you see x, plug in a. So a cubed minus a. That is fa. Okay? So this is something on the top. On the bottom, it is just h. Now you simplify something on the top. Remember we have a formula for this one. I'll write down the formula. X plus y cubed equal to this is the formula to expand the cube. Okay, apply this formula to a plus h raised to power 3. So it should be a3 okay. This is a plus h raised to power 3. Next, take away the bracket. So you have minus a minus h. And now take away a second bracket. So minus a raised to power 3 plus a. There are some cancellation. So positive a, negative a cancelled out. Positive a cube, negative a cube cancelled out. Okay. So we have and on the bottom you have h. Okay, don't forget on the bottom you have h. Okay, keep on going. So on the top, I will take h out, factor h out. So I have a squared plus 3ah plus h squared plus 1. So this is something on the top. On the bottom is very simple, is h. Okay, so now you have cancelled out h on the top, cancelled out with h on the bottom. So the final answer would be 3a squared plus 3ah plus h squared minus 1. This is the final answer. Okay, any questions? Okay, so this is the one question. Thanks for the student who contribute to this question. Second question, simplify this expression. Simplify this expression. So this is something on the top, something on the bottom, fraction. On the top, we noticed you can take away 5. When you take away 5, AD becomes 16 t squared because 16 times 5 equal to 80. When you take out 5, 40 becomes 8 because 5 times 8 equal to 40. So on the top, you take away 5. On the bottom, you use formula. The formula is x squared minus y squared equal to x plus 1 y times x minus 1. On the bottom, you apply this formula. Okay. In order to apply this formula, the bottom the bottom 16 t squared minus 1, it is the same as 4t squared minus 1. Do you agree? 16 t squared minus 1. The reason I write 4t squared minus 1 is that I want to apply this formula. So on the bottom, I have 4t plus 1 times 4t minus 1. Okay. This is on the bottom. Now continue on the top. On the top, it is actually this one, I will explain. It is actually 4t plus 1 squared. Copy down bottom. I will explain why I got that. On the top, you do factor. So why it is that? Remember last class we talked about this is the on the top. Now let's analyze this one. This is the quadratic. Okay. When you factor quadratic, one technique is break 16 in two numbers. Two numbers times together equal to 16. You say 4 times 4, 16. You can also say 4 times 8 equal to 15. Fine, you go ahead. Okay. So I just decided to use 4 times 4 equal to 16. This one, 1 plus 1 equal to 1. Then you use this clause. The result of the clause equal to 8. Bingo, you are correct. If you say 16 is 2 times 8, but when you do this clause, they are not equal to 8. So this combination is not working. Okay, so this combination is working. That's how I got 40 plus 1 here. 40 plus 1. Okay. So now, on the bottom, you have 40 plus 1, cancel out 1 with the bottom. On the top, you just have 1 40 plus 1. On the bottom, 40 minus 1. This is your final answer. Okay, maybe you can expand the top. It is 20t plus 5, or just keep this format, the same thing. Thanks for the student who contribute to this question. Any other questions? Okay, so let's continue our limit. Where we are. Okay, before break, we did this, okay? So the final answer 1/2. Next, we do another example. By the way, there are some confusion for this table here. There are some questions, okay? What is the meaning of this table? Where those data coming from? Or maybe this table here, the same table, yeah, here. It is on slide 6. Where the data coming from for this table? The data coming from this average velocity, this formula. When you plug in t equal to 2.5, when t equal to 2.5, evaluate this expression, you will get 18. Plug in t equal to 2.5, you get 18. Now, how do you get 16.4? Plug in t equal to 2.1. When t equal to 2.1, this expression, the average velocity is 16.4. Keep on going. Plug t equal to 2.01. This velocity, average velocity equal to 16.04. Okay? And why are we bothered to have this table? We want to see when t close to 2. You see, t is changed from 2.5 to 2.1 to 2.01, 2.001, 2.001. Do you agree t approached to 2 during this process? From 2.5 to 2.0001, it is said t approached to 2. That is the meaning. What does mean t approached to 2? Means very close to 2, okay? When t very close to 2, the average is 16.00004. And when we do the calculation here, we got this number 16. So this 16 very close to 16.0004. They are very close. Okay, that is the meaning to compare this final result with this number here. Any questions? Yes.
Example like that, will we have, would you recommend we use something like that if we have a question related to this in a test or a homework assignment?
Could be, yeah. Okay, because it is part of the course content. Yeah. So everything covered, even in the textbook, we don't cover, but it is on the course outline, could be on the test, on the exam, on the assignments. Okay, so we did that. Now let's look at this limits at infinity. So we have a function f(x) equal to 2x squared over 1 plus x squared. And this is the graph of the function. You can easily get this function on algebra. So how do I get this graph? When I reload this page, it will give me a blank, okay? Because I did a couple of examples, it will give me a fresh start. So now I want to do 2x squared over 1 plus x squared. So you just 2x raised to power square. And then you use the right arrow key. You see the insertion point is at the power position. Now I want insertion point in the regular position. Use the right arrow key. See, right arrow key, the insertion point will be in regular position. And then slash means over, okay? And on the bottom you have 1 plus x squared. Okay. So when I press enter, I will get the graph. Okay, so this is the graph. This is the graph. Okay, so what is the question here? The question asks you, what is the limit when x goes to infinity? This sign, mathematics, we call infinity. It is a very big number, very, very, very big number. Okay. Okay, so from this graph, if I zoom, so when x goes to very, very big, okay, so what is y goes to? Looks like, did anyone see the pattern? When x is a very big, either a very big positive number or negative number, where is the y? Can anyone just observe the graph, get the answer? When x is very big, either positive big or negative big, where is y? Can you just looking at this diagram to give a number? Yes.
Would the y be somewhere between -5 and +5?
You said -5 is here.
Oh, no, sorry, I mean,
This is positive 5.
sorry, 2. My bad.
Yeah, close. I just need one number. That number illustrates when x is very, very big. Where is y? Yes, and then here. 0 and 2. So we have two answers. One is 0, the other is 2. Okay, listen up. When x is very big, see, x becomes bigger and bigger and bigger and bigger and bigger. Where is y? Can I have the third opinion? We have 0, we have 2. Which one is correct? Third opinion. Which one do you support? Yes. 2. 2 is correct. Okay. 0 is correct only when x goes to 0. When x very close to 0, y is 0. If I change the question, what is the limit when x goes to 0? You are correct, 0. But the question asks when x is very big, very, very big, where is y? Y is 2. When x is very big, see, x goes very big, y is 2 here. Thank you for your participation. And this table illustrates when x equal to 1, fx is 1. When x is 2, how do you get 1.6? So you plug in x equal to 2. When x equal to 2, you get 1.6. This just illustration. How do you get this table? Okay, etc. When x equal to 1,000, what is y? Y is 1.9999. So when x equal to 2,000, y may be 1.9999999. I don't know. Okay, you see, this number very close to 2. Very close to 2 because our nature of the graph, remember we did the graph like this, but never exceed 2. Any questions? There is a rule for this function. Did you notice on the top, what is the degree? Remember both the top and the bottom are polynomial, and the polynomial has a degree. The top degree is 2, okay? The bottom degree is 2. When the degree is equal for bottom and the top, the limit, it is just the ratio of the coefficient. So what is the coefficient for this x squared? 2 coefficient. Yes, question?
Sorry, I just want to make sure you said the limit is the ratio of the coefficient.
When on the top you have x squared, bottom you also have x squared. The degree is 2, right? Yeah. And then the result of this limit, it is just the ratio of 2 numbers. One number is the coefficient on the top. The other number is the coefficient on the bottom. The coefficient refers to the x. So this is actually 1 times x squared. This is 2 times x squared. That is the rule. Now I give you another example, okay? To find out limit x cubed minus 1 over 1 plus 5 x cubed. What is the limit of this one? When x is very big. You use my rule. Can someone try what is the limit of this one? Yes. Wow. Because when you have degree equal on the bottom and on the top, you just use 1. This is 1 times x cubed. This is 5 times x. That's it. Shall we try another one? Okay. Because this is very handy, this rule, okay? Where we are. Okay, try another one. Find the limit x very big, and then what is the limit of this one? Four x squared minus 2x cubed over 5x plus 7x cubed. What is the limit of this one when x is very big? I know you must have right answer, so I will not call you. You must have right answer. I want another student to try. Yes. It is what? Where is 12? I don't see 12. It's just negative 2 over 7. It is just the highest degree, the coefficient of the highest degree, the ratio of two highest degree, the coefficient for, okay? Okay, thank you for your participation. Okay, so that is the limit, okay, when x goes to very big. Okay, now, when we have this function, example 7, when x smaller than 0, fx is -1. When x greater equal to 0, fx is 1. This is fx, and gx is 1 over x squared. Evaluate. Question A, what is limit fx when x is very big? X goes to infinity. What is limit of fx when x goes to negative infinity? By the way, the infinity means positive infinity unless you specify this is negative number. See, this is negative infinity. Just infinity means positive infinity. Okay. Okay, first we draw a diagram of this fx. Okay. This is x. This is fx. When this is 0, when x is smaller than 0, it is -1. This point is -1. When x is smaller than 0, it is -1 fx. When x greater equal to 0, it is 1. Okay, so this one, I will use solid circle. This is 1. And for this -1, I will use this circle. So this is function fx. When x greater equal to 0, it is 1. When x smaller than 0, -1. This is given. What is the question here? The question asks you, what is the limit when x goes to a very big positive number? How do I know it is positive number? I just see this infinity. I don't see any sign. Means positive infinity, okay? Okay, so this is my x. When this x goes to very big, very big, the y always equal to 1, right? So the answer for this one, it is 1. When x is very big, limit fx is 1. Now, when x is negative number and very big negative number, what is fx? So when x is negative number and it is very big, y equal to what? -1 here. This is +1. So this is -1. Did you see that? When x is a very negative number, very big, y is -1. Any questions? Yeah. Okay. So this is item A. Item B, gx equal to 1 over x squared. 1 over x squared. What it looks like? Let's take a look at the graph of gx. So I will disable this graph by click this red circle. Then I will enter another graph, 1 over x squared. So typing 1 slash x squared. Press enter key. So this is the graph of 1 over x squared. Okay, 1 over x squared. So if I do let you see clearly, it is this graph. Okay. Okay, the question asks you, what is limit of gx when x is a big positive number? What is the limit of gx when x is a very big negative number? Okay, by looking at this graph, when x is very big positive number, very big, see what is y? Y is 0. Do you see that? When x very, very big, y is 0 here. And when x is very big negative number here, very big negative number, y is also 0. Okay, so the answer for this one, 0, 0, based on the graph. Based on the graph. Hello everyone, we have a class, no side talk, no socialize during the lecture. Remember first class we discussed the respect. Everybody, you pay a higher tuition, you want to get most of the learning experience. You are not sitting here to socialize. You can socialize during the break, okay, before class, after class. Thank you. All right, so any questions to find the limit? I based on this graph. If I do not have a graph, how do I know this is 0, goes to 0 when x is very big? How do I know without a graph? And I have no idea what this graph is. I don't have that software to produce graph. But I am asking to find the limit for gx. There is a rule. Did you see on the top it is 1? Can you consider 1 is the same as x raised to power 0? Anything power 0 is 1, right? Okay. And now, so on the top is x raised to power 0. On the bottom, x raised to power 2. So the degree on the top is less than the degree on the bottom. In that case, the limit is always 0 when x goes to infinity. I give you another example, okay? I give you another example. Find the limit x squared plus 1 over x raised to power 5 minus 10 when x is very big. Find the limit. When x is very big, what is this? X goes to infinity. So apply the rule. When the degree on the top is less than the degree on the bottom. The degree on the top is 2, right, of the polynomial. The degree for the polynomial on the bottom is 5, 2 smaller than 5. When this happens, what is the result of this limit? Speak out. When the degree of top less than the degree of bottom, yes.
It's 0.
Yes. Okay? You can change this number. For example, when x equal to 5, the bottom is x equal to this raised to power 7, it is still 0. And you can add the coefficient, doesn't matter. This still holds true, it is 0. As long as the degree on the top is smaller than the degree on the bottom, and the condition is x goes to infinity. Okay, it is 0. When x goes to 0, this one has different result. I will use the same example. When 10x raised to power 5 plus 1 over 9x raised to power 7 minus 10. You are asked the limit of x goes to 0. This is not 0, the result. When you get 0, you have condition. Condition 1, x goes to infinity. Condition 2, the degree on the top is smaller than the degree on the bottom. Then you have 0. But this one, x is not goes to infinity. X goes to 0. In this case, you can directly plug in x 0. So 10 times 0 plus 1 over 9 times 0 raised to power 7 minus 10. So the result is negative 1 over 10. This is the result. So pay attention to condition. Same expression. The first one I got 0. The second one I got negative 1 over 10. Same expression. Different condition. The first one when x goes to infinity. The second one, x goes to 0. Okay. Okay. There are when degree on the top smaller than degree on the bottom. How about when degree on the top is greater than the degree on the bottom? It happens, this situation, right? So I'm going to give you another example. When the degree on the top is greater than the degree on the bottom, ask you to find the limit when x is very big. When x goes to infinity, find out the limit. Okay. When the degree on the top is greater than the degree on the bottom, the answer is infinity. The answer is infinity. You get 0 when the degree on top is smaller than the degree on bottom, you get 0. When the degree on the top greater degree on the bottom, you get infinity. When x goes to infinity, pay attention to condition. When x is not infinity, x equal to goes to 0. If you have the same expression, the result is negative 3. Can you guess why? When x goes to 0, the same expression, you get negative 3. Yes.
Because the exponents are subtracted from each other by -2.
Yeah, because you plug in 0. This is 0, this is 0. You just get 3 over negative 1. So pay attention to condition. Okay. And also the same expression for x5 plus 3 minus 2x2. When x goes to 1, you get another result. When x goes to 1, what would be this result? You plug in, whenever you see x, you plug in 1. So 4 plus 3 2 minus 1, it is 7. See, the same expression get different result. Same expression, see, and I make up those examples. You cannot find this example anywhere in any textbook, in any reference, because I just made it, this example, okay? All right. Okay. So this is a limit at infinity, okay? And this one here, you see this one, why this is 0? 1, because this one on the top is the same as x raised to power 0. Term n always greater than 0. So when the degree on the top is smaller than degree on the bottom, and when x goes to infinity, you get 0. Okay, this one, apply my rule without doing any calculation. Just compare the degree on the top with the degree on the bottom. What can you get? Yes, 1. Correct. When degree on the top, smaller degree on the top is 2, the highest degree. Degree on the bottom is 3. When degree on the top, smaller than degree on the bottom, 0. On condition, x goes to infinity. Okay, on condition. If the same example, if I ask you, what is x goes to 0? When x goes to 0, what is this limit? So this is it. What is the limit of this one? Same expression. You just plug in x is 0. 0 minus 0 plus 3. 0 plus 1 equal to 3. Okay? And the next example, what is the limit when x goes to 2? The same expression, x2 minus x plus 3 over 2x cubed plus 1. Same expression. When x goes to 2, you just plug in x is 2. 2 raised to power 2 minus 2 plus 3. 2 raised to power cube. So 4 minus 2 plus 3. 2 times 8 plus 1. 5 over 17. Okay. Same expression, I got 3 different results because x goes to infinity, x goes to 0, x goes to 2, x goes to any number. If you can do these 3 situations, you can do x goes to any number, right? Okay, one-sided limits. We finished session 4 of chapter 2. Now we are going to do session 5 of chapter 2, one-sided limit. Okay, consider this function f(x). When x is smaller than 0, it is x minus 1. This graph is x minus 1. When x greater equal to 0, it is x plus 2. This graph is x plus 1. Okay. And we have, by just looking at this graph, can you say what is the limit when x goes to 0? Just looking at this graph, don't look at anything else. When this is 0 here. When x goes to 0, where does this f(x) go to? Yes. Yes, questions? Anyone want to try? When x goes to 0, where is the limit of f(x)? Yes. 1? 1 and minus 1? Close. Yes. Just 1, okay. Just -1, maybe. Oh, there are 7 probabilities. 1 and -1, probability 1, probability 2, just 1, probability 3, -1. Do we have false probability? This one does not exist. You see, there is a big gap here. So the limit does not exist. But your answer is 1, -1 is a good try. We do have limit equal to 1. Why? When x goes to 0 from positive sign, when x from this side, when x goes to 0 from this side, you got 1. Okay? When x goes to 0 from right-hand side, you got 1. And then when x goes to 0 from left-hand side, when x goes to 0 from left-hand side, you got -1. You got -1. In order to have a limit exist, we enforce a policy. The policy is left limit must equal to right limit. Here, this one is the, this -1 is actually the left when x go to 0 from left. So left limit, and this one is right limit. When left limit is not equal to the right limit, the limit does not exist on that point. When left limit does not equal to right limit, in this example, right limit equal to 1, left limit -1, they are not equal. When they are not equal, the limit does not exist at that point. Okay, so under what condition can we say a limit exists? There are conditions. If when x goes to x, fx is L, this is true. If and only if right limit equal to left limit and equal to the same number. When left limit equal to right limit equal to same number, we say that limit exists. Okay, look at this example. Fx is a -x when x is smaller or equal to 0. So this graph, this straight line is -x when x smaller or equal to 0. And when x greater 0, fx equal to square root of x. This graph is square root of the graph when x greater 0. Okay. So this is a fx. Question A, show that when x goes to 0, fx exists by studying one-sided limits as x approaches 0. So use this I don't have solution on the slide. I will provide solution here on the blank space here. So question A, we need to calculate limit when x goes to 0 plus, means from right hand side goes to 0. And then we need to calculate x goes to 0 minus, means from left hand side goes to 0. to calculate fx, limit fx. So when x goes to 0 from right-hand side, look at this is x goes to 0 from right-hand side. Fx goes to 0, obviously, okay? Now, x goes to 0 from left-hand side. This is x goes to 0 from left-hand side. Fx is 0. So left-hand side equal to right-hand side, that's why this one exists. So this limit is 0. Okay, we proved A, question A. And the question B, Gx. Gx said, when x smaller 0, it is a -1. So this line represents -1. When x greater equal to 0, it is 1. This line represents 1. Question B, show that when x goes to 0, Gx does not exist. Prove Gx does not exist. So I will write down solution here. To do that, we need to write down the left limit and the right limit. So right limit is when x goes to 0 from right-hand side, Gx. So when x goes to 0 from right-hand side, you use this approach. Goes to 0 from right-hand side, and y goes to 1. Okay, y goes to 1. And then when x goes to 0 from left-hand side, what is Gx? This one, when x goes to 0 from left-hand side, from left, y is -1. As you can see, right limit is not equal to left limit. That's why Gx does not exist. Okay. Any questions? Okay, shall we take a second break? Come back at 8 o'clock, 10 minutes break, we continue. Okay, break back at 8.
Yeah, so I just have a question next. So I was going over a question on the online side, and I was kind of confused about, like, if I looked at it, I believe it was a different asking for -2 or 3 at this particular balance. So my question is, when I looked at the recipe, it showed me definite interval that I could call would that correlate to, let's say, for example, when it says -2 to 3, I would go to 5, or would I go all the way to 6? For the
So the interval from next to this, that is the question, right? Now I call the question. Now, this interval, the next is square bracket.
Yes.
3, 1 bracket. Now, you are correct.
Oh, okay, good. I thought that I was confused because I thought that I had to, because I was going by the textbook, I indicated the interval line with a different color than the actual line. I thought that I had to go all the way to the end to finish it.
You go all the way to the end, only one is a very big number.
Oh, it's then, oh, okay.
Only
Okay,
one is a big number. When you have specific number like this, you end up with big number.
okay, good. Thank you.
Good question.
Oh, thank God. I had a feeling I just wanted to be sure. Thank you.
Yeah, you're welcome.
I just had a quick question. I remember doing this back in high school, but I forget why we do this.
We want to get rid of the square root.
Okay.
When we want to get rid of the square root, we always multiply the
Yeah. Yeah. Okay. And then over here, like, why do we have to do this? Like all of these
Thank
steps?
you. Because original question has x raised to power 3. And the question asks you what is x a plus h. So whenever you see x, you plug a plus h raised to power 3.
So anytime you see
Anytime you see x, plug in a plus h.
okay.
So this every time you see
Okay,
x,
so
plug in
then
a.
H3 minus then and then what was this part? Where did this part come from?
Okay, good question. So up to here, don't look at what I covered. Just here, this part is x a plus x.
Oh, and
Because this is x cubed minus x. X is a plus x. Yeah, this part is x a.
Okay.
This part is x a.
And so f at a, we technically just plug in this.
Whenever you see x plus a, so you got a cubed minus a.
Okay, perfect. That makes sense. And then on this side, so like, what was the rule here? Was like the coefficient of i's degree is ratio, and to make the ratio like 2 over 7.
Okay. When you have a degree on the top equal to the degree on the bottom, it is just the ratio of the coefficient, the height degree of coefficient.
So that's when, so it's like, if you were to get a question, you just look to make sure the degrees are same on the top and the bottom, and you go whichever one is highest. Because what would happen if this was a 2 here? If it was 5x squared plus 7x cubed, would it still be the same?
No. If this is 7 times x squared, for example, okay? And if the top is the same, you just change this to 7x squared. This is the situation when the degree of the top greater than the degree on the bottom, and when x is infinity, the answer is infinity, very good number.
So if this is still 3 though, if this is still cubed, and this bottom one is still cubed, but this is squared and this is squared, like if we get a question
We
like that,
only care about the highest degree. We don't care about this part.
okay, so because this is, and so if this was like 1 here, and this was 1 here, we'd go with this one, right?
Exactly, yeah. Yeah, we go to the highest degree from the top and the
Okay.
bottom.
And then with this one, there was an example on the board. I forget what slide it was, but you're saying one of the limits is 1, one of the limits is -1, and then 2 of the limits is 0. One of them was like infinity, so like negative infinity limit is like negative infinity, limit is positive infinity. I was just wondering like how you got the numbers appear. I know it was using a graph.
You have to tell me which slide, yeah. Tell me which slide.
It's the guy in
This one.
Oh, this one. Okay. So this one, the question is, ask you what is the limit of fx when x goes to infinity.
Right.
Okay. I said it is 1. The reason is the graph of this fx is here.
Right.
This line and this line. So when
So because it goes to infinity that way, this is at 1, and then since negative infinity, that's down there, so that's the negative.
Yeah.
And then the limit of g at x, which is here.
No, the gx is another question.
Okay.
Gx
Oh,
see,
okay.
is 1 over x squared, is another graph.
Oh, okay.
This is gx.
Okay.
This is gx. This is fx. Fx. This is gx. They're
Okay.
different functions.
Okay, so so there were 2 different questions. Okay. So then the way they got 0 here, how did we get 0 again for B?
So this is the graph of gx, okay? And the question asks you when x very big, x very big, x big, did you
It's
see it
getting
is
closer to
0?
0.
Yeah.
Okay.
Okay.
Okay, that makes sense. All right, thank you.
You're welcome.
I think you're right. Oh, yeah. Yeah. Yep. Thank you. Yeah, it's a lot.
No, I just started with summer.
All right. Welcome back from break. Before the break, we did this example, okay? And we showed fx limit when x goes to 0 equal to 0 because the right limit is 0, left limit is 0, And for function gx, we showed gx does not exist because the right limit for gx is 1. The left limit for gx is -1. When you have right limit not equal to left limit, the limit does not exist. So now let's define a terminology, continuous function. What is a continuous function? If a function satisfies 3 conditions, we call the function is a continuous function. 1, the function is defined. 2, the limit is exist. 3, the limit equal to the function. When a function satisfies with these 3 conditions, we say the function is continuous. The intuitively understanding of the continuous is that a function have this one, it is continued. The continuous is just like the plain English. It's continued, it's never broken. Okay, so this function is continued. This is continued. Let's take a look at an example. Find the value of x for which the function is continuous. Fx equal to x plus 2. So we all know this is a straight line, x plus 2. So this is continuous everywhere. It is continuous at this point, it is continued on all the points on the real number. Okay. Now let's examine function gx. Function gx is it has something on the bottom. When we see something on the bottom, we have a condition. We assume something on the bottom is not equal to 0. Okay. So this function, when x equal to 2, gx does not exist. When x equal to 2, gx does not exist. That's why gx is not continued at x equal to 2, but gx is continued everywhere else except x equal to 2. When x not equal to 2, gx is continuous. When x equal to 2, gx is not continuous. And the function hx, when x not equal to 2, it is this straight line, x plus 2, when x not equal to 2. When x equal to 2, it is this point here. When x equal to 2, it is equal to 1. So this number is 2, this number is 1. When x equal to 2, hx equal to 1. So in this straight line, x plus 2, you should have a circle here. When x equal to 2, take this circle, not a solid circle, okay? That means when x equal to 2, y equal to something else. In this case, when x equal to 2, hx equal to 1. Graphically speaking, so this function hx has broken at this point. Okay, at this point, it is not continuous. It is broken at this point. Because at this point, it is suddenly equal to 1. When x equal to 2, this point is 1. this point is 2. Okay. But the question asks you found the value of x for which the function is continuous. So the answer for h, I'll write down. hx is continuous when x not equal to 2. When x not equal to 2, that gx is continuous. When x equal to 2, it is not continuous. Okay, and then we have this continue, this capital Fx. Capital Fx equal to -1 when you have x smaller than 0. It is equal to +1 when you have x greater or equal to 0. So the question asks you, find the value of x for which function is continuous. So the function for capital Fx is continuous. Capital Fx is continuous when x is not equal to 0. When x is not equal to 0, it is a continuous function. Okay. And this gx, when x greater 0, it is 1 over x. This graph is 1 over x. When x is a negative number, this gx is -1. The question is, find the value of x for which function is continuous. Okay. So again, this is continuous when x not equal to 0. Same conclusion as here, both g and f has the same conclusion. They are continuous when x not equal to 0. So for example, this graph, very smooth. See, it is continued, never broken. And this is continued, never broken. But at x equal to 0, it is not continued. Questions? Yes.
Sorry about that.
Okay. Properties of continuous function. You can read over this by yourself. I just want to go through examples. Use example to illustrate the properties of continuous function. Okay. Example 3. Find the value of x for which each function is continuous. So question A, this fx is polynomial. Polynomial is continuous everywhere. Okay, is continuous for all x. Any x will be continuous. If you plug in, it is continuous. Question B, find x so that gx is continuous. This gx is a rational something on the top fraction, okay? On the top you have polynomial, but on the bottom you also have polynomial. Focus on the bottom part. The bottom part always positive number, will never equal to 0. When you have something on the bottom will be 0, you are concerned. This one you don't care because the bottom always positive number. Okay, so this gx would be continuous for all x. It is continuous for all x. Gx. Now question C. Hx. Hx is not continuous for all x because on the bottom, if I copy down the top, the bottom, if I factor the bottom, so 1, 1, negative 2, negative 1, so I get x plus 2 times x, or x minus 2 times x minus 1. X minus 2 times x minus 1, the result would be x cubed squared minus 3x plus 2. So on the bottom, when x equal to 2 or when x equal to 1, hx does not exist. Okay, hx is undefined. So if you take away this point, hx is continuous. So the answer is hx is continuous when x not equal to 2 and when x not equal to 1. That is the solution. When x not equal to 2 and x not equal to 1, hx is continuous. Questions? Okay, intermediate value theorem. And this theorem is very interesting. So let's look at this theorem from this diagram first. So if f is a continuous function, you see this line continuous on an interval a and b, okay? And if m is a number between fa and fb. So first of all, what is fa? When you have this point is a, fa naturally is this point. When you have this point is b, fb naturally would be this point, right? And now if you have a m between fa and fb, this is m, okay? There is a conclusion. At least one number c between a and b, this point is c. At least one number c, such that fc equal to m. See, this is fc equal to m. This is intermediate value theorem. Okay. Why here at least one number c? Because I can find two numbers. I can find three numbers, but at least one. This is an example. You have two numbers. You have three numbers, C1, C2, C3. These three numbers line up between A and B, and the result of these three numbers all equal to M. So FC1 equal to M, FC2 equal to M, FC3 equal to M. That's why we say at least. This picture is 1, so FC equal to M, but this second picture, we got 3 points. They're all equal to M. Okay, so this is the intermediate value theorem. Graphically, understanding this theorem, if you have a number between A and B, this is A and B, there must be a number between FA and FB. That is this theorem. And this is the existence of zeros of a continuous function. So if this is f, if this is a continuous function over the interval a and b, and if fa and fab has a opposite sign, so this is fa, this is fa, positive number fa, but FB negative number because this is 0. FA is positive, FB is negative. When this happened, at least one solution for fx equal to 0 means this graph must cross x-axis. When you have FA positive, FA positive, when you have FB negative, this curve must cross x-axis. Cross means there is a solution for fx equal to 0. Okay, and this is at least one because I can have 2 points. See, in the second diagram, FB greater 0, FA smaller 0, and the curve across x-axis 2 times. One is at C1, the other is at C2. There are 2 points such that the function equal to 0. I found 2 points. At those 2 points, the function is 0. That's why it mentioned at least 1 point. Okay. It is okay. This is the existence of a 0 of continuous function. So this diagram illustrates everything we talk about. There's a condition for continuous function. If a function is not continuous, see this graph, this function is not continuous at this point. It has a broken point. This function is not continuous. You cannot apply the intermediate theorem. Okay, so in this function, FB greater 0, FA smaller 0, can you say there is a point, this graph across x? No, this graph does not across x-axis. That's why this function does not have 0, because it does not cross. It does not like this. No, it does not have this line because it is broken. It is not continuous. Okay, let's look at the example. We have a polynomial fx, x cubed plus x minus 1. Because it is polynomial, it is continuous for all x. And now let's figure out what is f0. So f0, whenever you see x plug in 0, that is f0. So it is -1. And what is f1? Whenever you see x, plug it in 1. Okay, so we got f0, f1. f0 smaller than 0, f1 greater than 0. Okay, so we get an interval from 0 to 1 based on theorem 5. Okay, so what is theorem 5? This is theorem 5. Okay, when you have FA greater 0, FB smaller 0, and when this function is continuous, they must cross x-axis, means they must have a 0. This point is FC equal to 0. Okay, and our example, we have FA smaller than 0, FB greater than 0. So between 0 and 1, there must be a point such that it is, I'll write it down, there must be a point between 0 and 1 such that, I call that point, let me use the same, there must be a point, let's call that point is C point. There must be a point such that FC equal to 0. Because I got smaller than 1, greater than 1. I'm very sorry there is no side talking, okay? If you have questions, ask your question. Okay, thank you. Okay, so how do we find that point? That is the question. Okay, this is interesting part. Now let's, we don't have a graph for this, but if you want a graph, I can produce one, x cubed plus 1 minus 1. No side talking. Thank you for so brief to speak up, to stop this behavior. It's not acceptable, okay? Affect all the students. So I'll try to graph x cubed plus 1 minus 1. So this is the graph, how this graph polynomial looks like. You get idea how this polynomial looks like. Okay, it looks like this if I make it bigger. Okay. And now we have this graph, and we locate the interval between 0 and 1. From this graph, maybe I want to copy this graph. So this graph, as we can see, we are focusing on 0 and 1, between 0 and 1. So maybe this is 0 and 1. Okay. If I want to make this bigger, so our focus is 0 and 1. So this is 5. This is 0. 1, 2, 3, 4, 5. So this point is 1. This point is 1. Okay. So when x equal to 1, y may be equal to somewhere here. It is positive number. When x equal to 0, y is here, negative number. And the intermediate theorem said there must be a point such that, let's say this is C, such that FC equal to 0. It is true here, as we can see here, because we have F1 greater 0, we have F0 smaller 0. There must be a point C between 0 and 1, and FC equal to 0. Our question is, what is that point between 0 and 1? Is it 0.5 or 0.8, 0.7? Is that clear? We try to find out this point C. C is here, such that FC equal to 0. That is our task. That is our task, okay? So how do we do that? Okay, how do we do that? We can evaluate the midpoint. We start with evaluate the midpoint of 0, 1. So midpoint is 0.5. We locate 0.5. So we found out F 0.5 is negative 0.375. How? So F 0.5 equal to 0.5 raised to 3. 0.5 minus 1, and you get negative 0.375. Okay, so F 0.5 is negative. So in this diagram, this is the maximum. You have this point is 0.5. You see, it is a negative number. Did you see that? This is negative number. When at x equal to 0.5, f is negative number. So your search narrow down to 0.5 to 1. Next time you search. So we began with 0 and 1. Now we narrow down 0 and 1 to 0.5 and 1. Why? Why we don't look for 0 and 0.5? Why are we looking for at 0.5 and 1? Because f1 is greater than 0. Now we found f 0.5 is smaller than 0. When you have 1 is greater than 0, the other is smaller than 0, this curve must cross the x-axis. So our focus is focused on 0.5 and 1. You get it? Okay, so 0 must be between 0.5 and 1. And now you repeat the process, okay? From 0 and 1, you found the midpoint. What is the midpoint between 0.1 and 1? You add those two numbers divided by 2. The midpoint is 0.75. Okay, and this time you calculate what is f 0.75. Okay, how do you calculate f 0.75? Whenever you see x, plug in 0.75. So this is original function, x cubed plus x minus 1, and you get 0.17. This is a positive number. Okay? And remember we have f 0.5 smaller than 1. Now we get f 0.75 greater than 1. So we narrow down again. So our focus should be -5 to -0.75. This is our focus now. Because 1 is positive, the other is negative. There must be a 0 between these two numbers. So you continue find the midpoint of these two. Okay? So you keep on this. So where we are, 0.5, 0.75. So we are in here. You keep on going. Okay? You keep on going. We did number 1, number 2, number 3. You keep on going. Keep on narrow down. Keep on narrow down. Okay? So finally, we found this. 0.679 to 0.68. Finally. And we can confidently say the C point we try to find, we try to find point C such that FC equal to 0. Okay? And when you at step 9, so C must belong to 0.679 and 0.683 must belong to this one. Is that clear? You continue from the midpoint of this one. And you will get that number close to C. Okay? So any questions? How do you find the 0 point such that FC is 0? Okay. Any questions? So use the GeoGebra, you plug in this function, see here, type in x cubed plus 1 plus x minus 1, and you zoom in, you see where, oops, this will undo it. You see where is the C? C is this point. It is between 0.68 and 0.685. C is at here. We found it. with the help of this graph. Even without this graph, if you don't know what this graph looks like, you just use this method. Positive, negative, must be 0. Positive, negative, must be 0. Narrow down your search. Okay. All right. So in summary, what we did today, chapter 2, session 4, chapter 2, session 5, it is all about the limit. What we did is just about limit. Make sure you do the examples in the textbook, redo the example in class. Last announcement about help hours. So when you're stuck, where do you go for help? You go to Brock University Mathematics Department. And then you found the help hours. So money. So last item, I just want to show you where do you get help after class. Somebody is there every day to help you for MATH1p97. And go to math department. The physical location as Mathematics Learning Center, MCJ 434. Okay, this is Mathematics Learning Center, MCJ 434. And the detailed schedule is here. Oh, they might haven't posted yet. So go to physical location here. They have a post. Somebody is there every day. MCJ 434, Mathematics Learning Center in Mathematics Department. Okay. That's all for today's lecture. Thank you so much for your participation. Have a great week. Keep an eye on your upcoming due date. No extension for any assignment. Okay. Okay. Good night. Love your participation. Bye.
I have a curious question. So we all got an email about office hours. Are you going to be like online for office hours, or is that like when we drop by every Tuesday?
The email I posted, it is a Tuesday. I will be on Teams. It is from 10 o'clock to 11:40 or 11:30.
Sweet. Oh, so we can just like ask you any question online. And then...
Yeah. You can ask questions online. Yeah. Okay.
Thank you.
Yeah, you're welcome. You too. Yes, questions?
I just want to listen to your class. I just didn't visit your class.
Oh, this is your first time. So please read the course outline on the bright space. Okay, bright space. You know bright space?
Yeah.
Okay, read course outline. Last class we did chapter 1, chapter 2, session 1 to session 3. This class we did session 3, session 4, session 5. Okay, read textbook by yourself. Try to find a study partner to try to find people you can take a notes of them. A PowerPoint slide is posted on bright space. Go through there. Okay? Yes.
Do you post like your annotated slides or no?
The underneath, no.
No?
No.
Okay.
Yeah. Okay. You make a note. Okay. Yeah.
Have a nice week.
Thank you. Okay.
Just a quick question. I know you did show it on the screen. But in regards to the Math Learning Center Help Center, is it like if you go from Monday to Thursday, is it from like 9 to 4, or is it just
No,
based on
it is just there are time slots. They haven't posted online yet. This is for fall term. So something like that.
Okay. So the
Time frame, something like that.
okay.
But this is for last semester. They haven't uploaded the new schedule yet. The new schedule is available physically on that department.
Okay.
But online, maybe in tomorrow or the day after tomorrow, you'll see something like this.
Okay. All right. Thank you very
Okay?
much.
You're welcome.
You have a good night.
Good night. Hello.
Questions that you had assigned on the break space, that's the ones that are under like the link, right? For the homework questions?
There are two kinds of homework. One is online homework.
Yeah.
The other is written homework. Which one you are talking about?
You want me to pull up? Can I show you? If I
Oh,
pull
yes,
up?
please. Yeah. So that I know what you are talking about.
Can you ask a question?
Yes, give me 1 second,
problem.
okay? I will try to